Hello, ladies and gentlemen. So today we're just going to be identifying conics. So we're trying to see what's what just by looking at a problem. So first we have to do now, and this is an important skill for exams and whatnot. We have to write the equation in general form. And so here is the general form. Okay, notice how we have no fractions or anything, but our original over here has fractions. So how do we fix that? Well, you're going to multiply by the LCM, the least common multiple. And so the least common multiple of the bottom, 4 and 9, is essentially 4 times 9. And so 4 times 9 is just 36. So then our goal is to multiply everything times 36. And so we do some quick distributive property to each piece. And so we end up with this, okay? We end up with 36. We can't do anything to the top yet, so I'm just going to write it out, over 4, because this is over 1, so the bottom is also multiplying out, plus 36, again, can't really distribute yet, so just write it in, over 9, and then equals 36 over 1. Now that over 1 doesn't really do anything, and so now we can start simplifying. So the 36 and the 4, what's 36 divided by 4? Well, that gives us 9. So we have 9 times x minus 4 squared, because that canceled out with the bottom, so that gave us 9. 36 divided by 9 is 4, so this gives us plus 4, comma, y plus 2 squared, and that equals just 36, okay? So now we're going to try to distribute, but there's a problem. There's a square, so we can't just straight up distribute. That would be bad, okay? So instead we have to FOIL. In other words, x minus 4 times x minus 4. So I'm going to start in blue now. So 9 x minus 4 times x minus 4, and then plus 4 y plus 2 times y plus 2. And then we can just subtract 36 from both sides and bring it over to the other side. So that would be minus 36 equals 0. Okay? Now, some students like to distribute the 9 right away, but I recommend you don't. I highly recommend you just immediately start foiling. So some people call it rainbows. I know I used to call it that. So there and there, there and there. And so when you do that, it's 9 times x squared minus 4x plus 16. We're going to do the same, oops, sorry, not the 4. We're going to do the same thing with the bottom part, sorry, with the y part. So plus 4 times y squared plus 2y plus 2y plus 4, close it, minus 36. Now would be a good time to distribute the 9 and the 4. Okay, so let's go ahead and do that. We end up with 9x squared. And then so if we combine these two, we get negative 8x, and 9 times negative 8x would be negative 72x. And then plus 144, because that's 9 times 16. Okay, same thing, these two can be combined to 4y. So this becomes 4y squared plus 16y plus 16. And then don't forget the minus 36, and these still equal 0. Okay, now we can start putting stuff into the general form, which is right here. Okay, we don't really have an xy component, so we can just ignore it. So we start off with ax squared. So we find our x squared term and write it first. Then we move on to y squared. So we find our, let me actually start highlighting those. So we find our y squared term and just plop it there. So plus 4y squared. Okay, next is the x term. So x term would be right here. So minus 72x. All right, let's see what's next. I'll use purple. We have our y term. So our y term is plus 16y. All right, good. And the final term, which is the most annoying term of them all, is f, which is I need to combine all these. Actually, I didn't highlight the purple term. My bad. So we need to combine all of those brownish looking pieces, okay? And so when we combine them, just simple calculator work or just scratch work, that gives us 124. And here we have our general And so look at this. Now, let's identify what this was. This is an ellipse. Why? Because notice, x and y have the same sign, in other words, positive, positive, but they have different coefficients, in other words, what they're being divided by. And so that tells me that this was an ellipse. Okay? And so now let's go ahead and identify some more. Now, I actually forgot to mention something. So that's looking at this. But what if we're looking at this? Well, you only have to look at your two leading coefficients, the x squared and the y squared. You only look, and let me pick another color that I haven't used yet, orange. You only look at these two, and that's what the general form talks about. Okay? So notice, they're both positive, in other words, same sign, and they have different numbers or different coefficients. So that tells me that this was an ellipse because x and y squared have the same side but different coefficients. So we're going to do the same thing with the next couple of equations, and then you guys will work on some yourself. So let's see. We look at the first term, 3x squared minus 4y squared. Okay, so now let's check. We have x squared and y squared. Are they the same sign? No, they're not. So they have different sign. Well, let's go look at the ones that have different sides. So it might be, okay, same side. No, it might be a hyperbola. And that's it. That's the only one that says different signs. So this is a hyperbola. Okay. Now, sometimes we need to get it into standard form. So we have to move everything to one side. So here's how some steps. Move all terms to one side so the equation equals 0. So number one, we didn't have to do that, but number two, we do. Pay close attention to squared variables, and then look at coefficients in front of the square terms. So let's move everything to the same side. I'm going to move everything that way. So 0 equals, if I move the 2x squared, it's positive 2x squared, plus 2y squared, minus 3y, and then the 16 becomes negative 16. All I care about are these two. Now look at that. They have same sign and same coefficient. And so that gives me a circle. So this is a circle. When everything matches, you have a circle. All right, now, this next one, number 3, that's going to be a parabola. Because notice, I have no y squared. And that's what this one says. A parabola is either x squared or y squared, but not both. So I'm going to say only x squared. This is a parabola. Oh, I misspelled parabola. Sorry, guys. I'm a math teacher, not an English teacher. And so now, next step, we're going to move for the last question. Let me just separate these that way. There we go. I'm going to move this over to the other side. So I'm going to do a plus 3x squared. So this would become 3x squared plus 5y squared. And I'm going to subtract the 15 from both sides while I'm at it. We only look at the front. So same sign, but different coefficients. So same sign, different coefficients. That's going to be an ellipse. So this is an ellipse. So guys, just heads up, this is a great poster opportunity for those of you who are taking my class. So just saying, first come, first serve. And there we go, guys. We are essentially done. And then now let's look at this real quick. So if you have a BXY term, you have a rotated conic and must use the discriminant to classify the conic. The discriminant works to classify all conics. Okay, so let's see what this means. So what the heck is the discriminant? Now, the discriminant is an old thing that you've used before, so I'll start using a different color. I just use light red. So the discriminant is our classic b squared minus 4ac. That's the stuff that's inside the quadratic formula, okay, inside the square root. Now, how do we use that? Well, we have to label. Remember from the general form, this is a, this is b, and I will be using the negative, okay? And then here is c. We don't really need anything else beyond that. Okay, and so we plug that into the formula. So b squared minus 4ac. Okay, and so in this case, we have negative 2 squared minus 4. A is 2, c is 1. So we calculate that. And so this equals 4 minus 8. And so we get negative 4. Now, what does this mean? Well, if it was a circle, it has to be less than 0. Okay? But it has to also be true that b was a 0 and a equals c. And that is not true. Okay? B was not 0. So b was not 0. And a did not equal c. So then, not a circle. Well, let's see if it was an ellipse. It's an ellipse if it's less than 0. Okay, so now we're looking at this one. So did we get less than 0? Yes, it's less than 0. And if these two things are true, and that is true, we got an ellipse. So this is an ellipse because it satisfied all the conditions of an ellipse. Now, if it was a parabola, we would have gotten a perfect 0 with the answer. And if it was a hyperbola, the answer would have been greater than 0. So this is another poster opportunity. Okay? And I'll let you guys fight amongst yourselves to see who gets it to me first. So thank you so much for watching this video, guys, and we'll talk next time.